Hello, can you guys hear me? Just hold on, I will check real quick. Yeah, we'll just start in 5 minutes. Okay, just 2 minutes. We'll wait for everyone to join. Then we'll start. Like Gokul, are you here? Because you had few doubts. Like my voice is audible. Voice and audio, video, everything is fine, right? Okay. So yeah, I will take your doubt as well. So with yes. Okay. So like if I will just wait 2-3 minutes more and like we'll start. Like we'll do this question. Gokul had a question on this. This is a good question. This I didn't cover, and this was also another question, like a gate PYQ, and another one is this. So we'll solve all this, then I will take all of your doubts. Mainly this will be doubt clearing about linear algebra, and next few classes we'll take more chapters as well as you finish along. So, like whoever in the chat box right now, you can tell like up until what chapter you have studied till now, and how are you feeling? How confident are you feeling about mathematics? हाँ इंडिपेंडेंट डिपेंडेंट बताएंगे बट उसमें लाइक देयर इज़ नॉट मच टू अंडरस्टैंड दैट ओके लाइक तो पहले अगर अभी वो गोकुल और वो बहुत लोग नहीं है तो आपका वो छोटा सा डाउट मैं समझाता हूँ इंडिपेंडेंट डिपेंडेंट एग्जैक्टली मेरे को नहीं समझ में आ रहा आपको लाइक वायर आर यू गेटिंग द डाउट फ्रॉम so if I have these matrix right if I have these matrix if you observe if I have this matrix so आप बोलिए like how many like are these two rows dependent or independent what do you mean by linearly like we're talking about linearity right? Like what do you mean by linearly dependent and independent if I can write this second row as a linear combination of this first row so here right I'll just add a new page so this is the row 1 is what 1 2 3 okay and row 2 is what this is 0 4 5 now am I able to like if I multiply with this sum with some scalar right if I multiply with this some scalar it's a lambda can I get this row 2 no right we I cannot get this row 2 so what will be the rank of this of this matrix this is a matrix right rank of this a matrix will be 2 because there are two linearly independent rows here that's why the rank will be 2 and if you want to understand through column as well you can understand through column as well so whenever you see right you have more columns than rows you will always go with rows why because the rank will be anyhow be less than or equals to number of rows here if you observe that can I write this let's say this c1 column right c1 column is this 1 comma 0 and your c2 column is this 2 comma 4 to 4 and your c3 column is 3 comma 5 okay so if I just can I write this like this so c1 equals to alpha 1 c2 plus alpha 2 c3 can I do this So if you want to find out how we can do this, right, what you can do is you can break this down. This is 1 0, and like this alpha 1 is a scalar. This can get multiplied to all of the elements. Whenever a scalar is getting multiplied with a matrix, it will get multiplied to all of the elements. So this will be 2 alpha 1, 4 alpha 1 plus 3 alpha 2, 5 alpha 2. Okay, so now what you can do is I can make to form two equations over here to find out alpha 1 and alpha 2. So here the first element of this column, right, should always be equals to 1. First element of this column should always be equals to 1. Just hold on. Okay, first element of this column will be equals to 1. So this is 2 alpha 1 plus 3 alpha 2. So this will be 2 alpha 1 plus 3 alpha 2. And this will be equals to 1. And the second row, right, second row should be equals to 0. So this should be equals to 0 equals to 4 alpha 1 plus 5 alpha 2. Now, are you getting valid values of alpha 1 and alpha 2? If you are getting valid values of alpha 1 and alpha 2, then whatever you have solved, right, that is correct. So here, if I solve these two equations, what will I get? If I multiply 2 and then subtract, right? If I multiply 2 and then subtract with this will be 2 and this will be alpha 2. So alpha 2 will be equals to simply 2, and if alpha 2 is 2, then alpha 1 is simply 6. This gets subtracted, minus 5, so minus 5 by 2. So now you put this back here, right? You put this alpha 2 equals to 2, this is 6, right? This is 6, and you put this minus 5 by 2. So this will be 1, first row will be 1, and if you put alpha 2 equals to 3 over 2 over here, this is 10, and this is 5 by 22, this is minus 10. So plus 10 minus 10 1 0. So you are getting a valid combination here. So you will say that yes, alpha 1 and alpha 2 are basically, like, I can write correct values of alpha 1 and alpha 2 valid values. So hence these two, like this column, right, is linearly dependent on this C2 and C3. Okay, so that's why one column is linearly dependent, but these two columns, right, these two columns are linearly independent, because I will not be able to write C2 as a scalar multiple of, let's say, alpha 3 into C3. Okay, I will not be able to write that. That's why. So I hope, like, Savit, your doubt gets cleared here. Okay, your doubt gets cleared. So you can write in the comment box, like, if your doubt is cleared or not. Okay, so this was about the dependent and independent rows. I will come to nullity as well. Okay, but before that, I want to, like, few students had confusion on this, like this question. So have you guys solved this question? Like, you can write in comment box if you have tried this question. This is a GATE 2019 question. This is a good question, right? This is a good question. Bhai yaar, 1 second. Okay, you are here, right? Okay, I will solve your doubt. I will come to your doubt later. Okay, so Savit, I will just solve this question first, then I will solve. Okay, Gokul is here. So you had this doubt in this question, right? So this question is actually good question. So I will tell you two methods to solve this. So first one is method 1. Okay, with examples. So I will tell you. I will take example. Okay, so they have told me that I have two matrices, right? Here, this is V1 and V2. So V1 and V2 are column vectors. So what does column vectors mean? So if V1 is something like this, AB, right? It is a column vector, so it will have only a single column and it can have multiple rows. That's what a column vector means. And V2 is another column vector. So I will name V2 as CD. And how they are writing this V1, V2? So M, right? M is a 2 cross 2 matrix. How is it possible? So if I write M, right? If I write M will be V1, V2, and if I expand this will be, like, if I expand V1, this will be AB and this will be CD. Okay, this will be my M. So what is my M inverse now? What is my M inverse? So my M inverse, right? Just hold on a second. Yeah. So my M inverse will be, because they are talking about M inverse here as well. In the statement, they are talking about M inverse, and M inverse is like this row vectors. So M inverse will be simply this, right? Like, you know what is the inverse of a 2 cross 2 matrix? That is very simple. So I will just replace the main diagonal elements D and A, and the off diagonal elements will be negative, minus C and minus B. Okay, and then a factor will also come, that is determinant of M, and determinant of M is what? It is AD minus BC. Okay, one thing, yeah, AD minus BC. So this is that scalar. Now next what have they told is that M inverse can be written as the combination of two row vectors. So my u1 of t is a row vector, so there will be two elements here, so and there will be two elements here, right? u2 of t, there will be two elements here. And what are those two elements? If I see here carefully, these are the rows, right, of M inverse, and they are the rows they have explained. So what will be this? So if I write here, this will be d minus c divided by a common factor, that is determinant of M. So the determinant of N I can write outside. This will be d minus c u1 of t, and your u2 of t will be minus b minus a. Okay, minus b minus a. So this is the u2 of t. Now what you can do is basically what have they asked, you can like prove the statements. So u1 of t times dot v1 equals to 1. So I will multiply u1 of t, like t means here transpose, right, into v1 should be equals to 1. Is it true? So I will multiply u1 of t. u1 of t is this, right, d minus c multiplied by v1, a times b. So the first, this d will get multiplied with a, so this will be ad, and then this minus c will get multiplied with this b, right, this will be minus bc. And you can see here, like, what is the order of this? The order of this is 1 cross 2, 1 row and 2 columns, and order of this is 2 cross 1. Hence if I multiply this u1 times v, obviously this middle order will get cancelled, only 1 cross 1 element I will get. That is exactly what we are getting here. So ad minus bc, one element, divide by, like, don't forget there is a determinant of M as well, right? So what is this? This is also determinant of M is also ad minus bc, right? So this will be equal to simply 1. So this first statement is like statement 1 of first option is correct. Let's check the second option. Second option also will be correct here. What you will do? So basically you can just hold on, do the same multiplication here, u2 transpose into v2. So what is u2? u2 is this, right, minus ba. So minus b times the first element here, c. So minus b times first element is minus bc, then this, right, this element a into d plus ad. And obviously don't forget I have a determinant of M as well, which is ad minus bc. What you are seeing again, at the numerator I have ad minus bc, and the denominator I have ad minus bc, so this will get to 1. Okay, and similarly if you check for the second statement, so this is for the statement 1, and if you check for the second statement, what you'll get? So if I multiply what, u1 transpose into v2, if I multiply u1 transpose into v2, so u1 transpose into v2, so this time u1 is d times v2, that is d times c. So it is d times c and minus here minus c times b, right? So no, minus minus c times d, so this will be dc, and divided by determinant of M, and this is anyways 0, so this will get cancelled. And you can prove it for the other one as well, u1 u2 transpose into v1, this will be also 0. Okay, so both of these statements will be correct. So here our answer will be both statements are true, so option C will be correct in this case. Okay, so what is the method 2 here? So in method 2, right, what you can do is you can write a special identity if you know about inverses. Okay, method 2 is this, that my M into M inverse equals to M inverse into M equals to I. Okay, this is what we know, right? This is what we know. Now here, right, my M is what? M is v1 v2 and M inverse is u1 transpose and u2 transpose. This is what my M and M inverse is, whatever they have defined in the question. So what I will choose is, I will just do this multiplication, right? I will just do this multiplication, and which multiplication shall I choose out of here and here? So here, right, if I choose my M as this here, v1 v2 and this u1 transpose into u2 transpose. Should I do this or do this? Both will do the same thing, but which one should I choose? That you have to say me. So this will be u1 transpose u2 transpose into v1 v2. This is equals to identity matrix. And how can I write identity matrix? This is a 2 cross 2 identity matrix because my m is 2 cross 2, right? So this will be 1 0 and 0 1. Okay, so now what you can do is this, right? These are rows. So if I multiply this row with this column, this will give me 4 elements, and instead of this, so I will choose this. I will not choose this. Why? Because this will give me a 1 element. Because this will give me 1 element, that is, this is 1 cross 2 and 2 cross 1. So I won't choose this, even though this is overall 2 cross 2, but this v1 v2 each, if I assume this as element, so this is 1 cross 2 and 2 cross 1. So I will choose this one. Okay, so if I do this, this will be u1 transpose into v1. This is the first element, then the second element, right? Row is into columns. So u1 transpose into v2, then u2 transpose into v1, and then u2 transpose into v2. Okay, so this should be equals to 1 0 0 1. Okay, so this, if I equate the each elements, right, this is equals to 1, this is equals to 0, so this is equals to 0, this is equals to 1. So like products are 1 and unlike products are 0. Basically it is the if you remember the property, this is the property of orthogonality, right? If you remember it correctly. So here u1 and v2 are orthogonal basically. So and you like both the statements are correct, so option C will be correct. So Gokul, you can say any comments like if your doubt got cleared or not. Okay. I like method 2, right? I know you were confused with method 2. Just here, why we are using this, why you are using this and why not this? Because this gives us a basically 1 cross 1 matrix, and this gives us a 2 cross 2 matrix. That's why we are using this, right? That I think that there would be the confusion. Else anywhere else, I don't think there won't be any confusion. Okay, we'll now move to this question. Okay, this second question. This second question also you gave me. So this is a good question. So if you haven't studied like vector calculus yet, right? So you can come back to this question once you study vector calculus. Okay, so basic funda here is that they are asking us that, like, a vector is given 1 2 3, okay, transpose the vector normal to the plane defined by w transpose x equals to 1. So I need to find a vector that is normal to the plane defined by this. So what is the plane that is defined? So let me write this x, right? This is just a 1. So here, what is w transpose order? Order of w transpose is what? Order of w transpose is simply if I like this, if I this is already in transpose format, if I transpose it again, this will be the same thing only, right? This will be simply w transpose will be simply 1 2 3. Okay, and what is the order? Order is 1 cross 3. Okay, so x has to be what order for these two finally get a result of only single element? X has to be order of 3 cross 1, right? So it has to be a column vector. Okay, column vector. So x can be defined as this x y z in 3-dimensional space. Okay, so how can I define the plane? The plane will be defined something like this, that w transpose is 1 2 3 into x y z equals to 1. So x plus 2y plus 3z equals to 1. Okay, so x plus 2y plus 3z equals to 1. This is the equation of the plane. This is the equation of plane. Now how to find a plane that is normal to this equation, right? So we use a concept known as gradient. So once you will study vector calculus, they will understand the concept known as gradient. So I have to find, this is the this is the plane, and to find the normal to this plane, right, normal to this plane, I have to use the concept of gradient, right? So this will be grad of f. So gradient is basically this, right? If you know grade, that grade, that's great. If you don't know gradient, that's you can study later on. So this will be simply I del x plus j del y plus k del z. Okay, so into x plus 2y plus 3z. Actually this one will go on the left hand side. This will be equals to 0. This is how we find the grade. So once you study vector calculus, there you will understand what am I doing here. So don't worry about this. -1. Okay, so grad of phi, what will be this? So this will be simply equals to I cap plus 2j cap plus 3k cap. And if I want to find a unit vector, right, unit vector will be divided by the magnitude. So magnitude will be under root 1 square plus 2 square plus 3 square, that is 9 plus 4 is 13 plus 1, that is 14. Okay, so this is the grad of phi. Now what are those? They are asked which is normal to the plane. So I can see I just need to find a vector that whose x1, y1 and z1 are in this proportion, right, 1 to 3, or they are multiple of this, they are linearly dependent. So here I can observe that 1 to 3 is present on this D option. Let's say this was 2 4 6, that would have been also correct because that is just linearly dependent. We are just, it is parallel, that vector is also parallel, so option D will be correct. Any other vector won't be normal, okay, because those are not parallel to that vector, right, whatever I found out. So vector 1 to 3 will be correct, so option D will be correct in this case. So Gokul, like you can say, if you have studied vector calculus, you will be able to understand this, or you can say, like, if you doubt clear, because gradient, I hope you have studied in basic engineering mathematics as well in your college as well, so you will be able to understand that as well. So Gokul, you can say. Yeah, so like only this part is, I think, the worrisome part, or like, okay, I think this will be also doubt. So once you study vector calculus, you come back to this video again, and then you will then you can study, right, then you can understand this completely. Okay, so this is the concept of vector calculus. This, right, this I have taught in my lecture of rotation matrix. I've taught about the matrix, but haven't solved this question, so I will try to solve this. So here as well, you can solve this using two methods. Either you remember the rotation matrix or you don't remember the rotation matrix. So what you can do is you can check all the options. Okay, that is the method one. Method one is check the options. Okay, so if you check the options, right, so basically what is happening, I have initially this vector with me. Okay, then what am I doing? I'm multiplying like u times okay, not this, I have initially u vector, right? I have initially, let's say I have initially u vector, then I'm multiplying a with this. If I multiply a with this, right, this shifts theta in clockwise direction. Theta is in clockwise direction, right, clockwise. So if I multiply a with this u vector, then she shifts theta in clockwise direction with v. So what you can do is they are asking us what will be the correct choice of a. So what is my u? U is yeah, u is shown here. U is 4 comma 3, right? So I can write this like 4 comma 3 into a should be equals to 5 comma 0. Now, like, method one is check the options. So if you check all the options, right, you will see that your option A is coming as the correct answer. So I will just show you with example. All the other options won't be valid. So this will be 4 by 5, 3 by 5, then minus 3 by 5, then 4 by 5. Okay, I'm multiplying this with 4, 3. So this, right, this will be 16 by 5 plus 12 by 5. So 16 by 5 plus 12 by 5, which is, am I doing anything wrong over here? 16 by 5, sorry, 16 by 5, not 12, 16 by 5 plus 9 by 5. So this will be 25 by 5, which is 5 itself. And this will be minus 12 by 5 plus 12 by 5, this will be 0. So option 1 is satisfying. So like from this, like with the options, you can solve this. Other method is this one, right? I have explained in my lecture. I think this was the lecture 12 or end, right? Last lecture, I think this was the last lecture. Okay, towards the end, I will explain that if I have a vector here, right, G, and if I want to rotate in the anti-clockwise direction, then this will be the matrix. But if I want to rotate in the clockwise direction, just I have to replace with theta to minus theta, theta to minus theta. So like I will do this here. So my rotation matrix will be like I am initially here. I want to like I'm initially here, but I want to rotate in the clockwise direction. So my initial matrix is what? Initial matrix is just hold on. So like this will be the answer. Just I will replace theta with minus theta. If I replace theta with minus theta, cos of minus theta is cos of theta, sine of minus theta will be plus sine theta. Okay, then sine of minus theta will be minus sine theta, and cos of minus theta will be cos of theta. Okay, and what is the theta? How do you find out theta? So here, right, if you observe, like how much angle am I moving? So what is the height of this? The height of this is simply 4. And what is the base of this? So basically, right, this is 4, and what is the base of this? So base is 3, right? Yeah, base is 3. Sorry, this is not the height. This is the height. Right? This is the 3 is the height, and base was 5. Okay. So basically, I'm just writing the height and the base of this triangle. So the base is not 5. Base is 4, right? And if I come back here, right, this will complete a total triangle. Okay, and this is the theta that I'm moving. How to compute the theta? Theta will be basically what? Tan inverse height upon base. So this is what? Tan inverse 3 by 4. So I think this is around 36.86 degree. If I remember, I will compute it. 3 by 4 is, yeah, 36.86. Now what I need to find out? I know theta, so I will just plug in the theta value here, right? So cos of 36.86 will be 4 by 5. Sine of 36.86 will be 3 by 5. This will be minus 3 by 5. This will be 4 by 5. Okay, so yeah, 4 by 5, 3 by 5, minus 3 by 5, 4 by 5. So you can remember the formula, but if you don't want to go with the formula, you can do like that also. Okay, you can directly do with this concept, like just option checking. But I hope you're understanding that I have a vector over here, and I'm just rotating it with some angle, and this will be the rotation matrix. And there are a few properties of a rotation matrix. Rotation matrix is always orthogonal and orthonormal. Orthogonal means if I just take the dot product of this and this, right, this will be 0. And orthonormal means if I just take the magnitude of each row or each column, it will always be equals to 1. So here you can see cos square theta plus sin square theta is 1. In column wise also, cos square theta plus sin square theta equals to 1. Okay, so this was basically about this question. So Gokul, you can say if you understood this question or not. Okay, you understood, right? Good. Okay, so these were the three doubts you had. Anything else? Okay, here, right here, as I was showing that this wavy curve, right, this is not for f of x or f dash of x. This is for f double dash of x, because I was interested to find the root of f double dash of x. That's why I had drawn the wavy curve here. So here, right, if I draw the wavy curve, I can see that at -3 the function will go to 0, at 0 the function will go to 0, and here I don't care about the sign of f double dash of x. I care of the sign of f dash of x, like how the sign of f dash of x is changing. So here if you see the graph, right, if I've just drawn it in Desmos, so at like this is -3 almost. At -3 what I can see that slope, right, slope here was positive. Now just suddenly after -3 slope becomes negative. So slope from positive to it goes to negative, right? What will be that curvature? And here slope goes from negative, here the slope is negative at around x equal to 0, slope is negative, then it goes to positive. Okay, so from negative it goes to positive, and from positive it goes to negative. So curvature changes. That's why there will be inflection points at x equals to minus 3 and 0. So that doubt also I think got cleared from you. Okay, so yeah, I think that doubt also got cleared from me. Like Shavit, Ayan, could you are you in the chat right now? So I will just take your doubt, and that will like we will finish this doubt clearing session, because these were the doubts that I got mostly now. Is it valid transformation by R equals? Yeah, that is a valid transformation. That doesn't affect the rank, okay. But you should not do it in the you should not do it in the same row. So like I can do this, right? This is row one. Let's say this is row one. This is row two, and this is row three. So what you can do, I can change my row one from row one minus two row two plus two three row three. I can do anything, right? But this won't change the rank. No changes in rank, okay? No change. No change. This won't change the rank, okay? Rank will remain same. Okay. This is a valid operation. Okay. Yeah. So I think most of the things are cleared. If Sabit is in the chat, he can say. Like Gokul, how much have you studied till now? Like what chapter you have studied till now? Integral calculus. Okay. Just finish that. That is like you can study through that from YouTube as well. Then you start like sequentially. Like which branch you are from, EC, right? So just do it sequentially, and that would be good enough. Okay. Okay. So what chapters have you finished till now? Like what subjects? I mean, not chapters. What subjects? Yeah, like what you can do is first, right now you can keep those other PIQ branches on hold. Like at least do EC, IN, and EE. These three you do, and you can practice the other ones later on. Okay, because first of all you have to finish your chapters as well, right? Whatever you have studied, your chapters you finish, and then you can do this, because you have to finish the chapters you have to study. So focus more on finishing the subjects now, chapters and subjects. At a later stage you can attempt the PYQs, okay? Because you need to finish all the subjects as well. That will be time consuming. Last question. Okay. That will be video on itself. Okay. That is present over here. Like if I can show you. Where is that? That is not present, right? Okay. I will upload uh within next week. Okay, I will upload that question. The answer is, I think it was 1 by 6. The answer was 1 by 6. Okay. But currently I am too busy, so I will try to upload that solution in the next question. You try to solve, no? You try to solve it usually. If I give the solution of everything, then like how you will develop your intuition. You have to develop your intuition as well, right? So that you have to develop. I hope, like Gokul, your doubt has been cleared. So we can finish this if all the doubts are cleared. Nullity, like if Saved is in not the chat box, so I will take his like nullity doubt next, because nullity is nothing, right? Nullity is basically the rank minus the number of unknowns we have. Okay, how many unknowns we have. So I don't think he's present, so I won't be able to explain the doubt here. Okay, we'll solve next. So yeah. So yeah, I guess like that's it for this video. And yeah, if you have any queries further, you can put it down in the comments below. We can have a chat again. So yeah, I will see you next time. Thank you.